record. I'm going to move you guys down here. I'm going to move this over here somewhere, and you guys can check your answers to the homework. Sarah is here, Julia is here, Daisy's sleeping. Emma, what's up?
Can we go over part C on the first one?
Definitely. I was going to wait till, I was trying to give Jacqueline a minute to get here, but she's not showing. So when she gets here, she gets here. Okay, so yes, I would like to start with number 1. Does anybody still need to check their answers? You have to use your voice because I can't see everybody's picture. Okay, then let's go to a fresh page here. And actually, I'm going to move you guys because I don't know, I find it weird when you're in the bottom of my screen. I just do. Okay, so we're looking at that first problem, number 1. Let's try to go through this sequentially. So again, I can't see all your faces and I need you to use your voice if you have a question. So do we need to go through part A? Do we need to go through part B?
I have a question for part A.
Sure. Wait. Now we got to let Jacqueline in because she's here. Admit. Okay. All right. Hang on. I got to fix attendance too. So try to ask your question and I will try to answer it. Actually, I assume she was here.
Can I just plug that integral into my calculator or do I need to show work for it?
In this, and I may not have put it, I apologize, you can use a graphing calculator for this. So yes, for part A, you could have just put it into the calculator. Okay? All right, so questions on part B. No problem, Jacqueline, we're happy to have you. Sorry that I just showed everybody that your computer restarted, but we're all good and we're all friends, okay?
Can we go over B?
B, we need to go over? Sure. Okay, so B says, is the amount of water in the pipe increasing or decreasing at 3 hours? So this is something we were talking about a little bit yesterday in the examples that we went over. And basically, I want to know if R of T minus, let's get rid of that mark there, D of T is bigger than 0 or less than 0. That's the question that I'm asking. Okay, so this is a problem that has 2 flows. R is the rate at which water is flowing in, and D is the rate at which water is flowing out. So if we're looking at that specifically for t equals 3 hours, I really just want to take r of 3 minus d of 3, just substitute 3 in for t in both of those equations. And I get, when I do it, negative 0.314, which is less than 0, which means that this number, the d of t number, is bigger than the r of t number. So remember, d of t is how much water is leaving the pipe, and r of t is how much water is coming in. So if more water is leaving the pipe than is entering the pipe, then the amount of water in the pipe is decreasing. Okay, does that make sense to whoever asked the question? Again, use your voice because I can't see you.
Yeah, thank you.
Cool. All right, so Emma, you wanted to talk about part C, right?
Oh, Dr. Getz.
Yes.
I just had a quick question on the way you did B. Is it okay if I subtracted the integrals at t equals 3?
No,
to see if they
it's
were
not okay.
zero?
No, because if you took those integrals, it would tell you how much water was in there. So that's not answering the question.
Okay.
The integral tells you how much water, the total amount of water that's come in, and that would be minus the total amount of water that came out, but it wouldn't tell you how it was changing.
Okay.
Okay?
Thank you.
Sure. All right, so part C, and C wants to know when the amount of water in the pipe is a minimum. Well, what I did is I said, okay, here's an expression that I'm going to use for how much water is in the pipe at any given time. And we talked about this a little bit yesterday, that you start with 30 cubic feet. And then I'm going to add water at this rate. So after whatever the time t is, I'm going to have that much water. Minus how much water has drained out. Okay? And I'm writing this because what I'm interested in is the max min for the amount. And if this is my function, how do I find the maximum or minimum of a function? I take the derivative, right? So I'm going to find a prime of t, and then what am I going to do with it?
Set it equal to 0?
Yeah, set it equal to 0. Okay. So when I take the derivative of 30 is going to be
0.
0. When I take the derivative of this integral, remember fundamental theorem of calculus, I'm going to just get whatever was inside the integral. And the same thing for over here. So this just tells me that my amount is going to be a minimum when the amount that the rain is coming in is equal to the amount that the water is draining out.
So could you just graph these and find their intersection?
Exactly. Exactly. And then I get, like I said before, I get t was equal to 3.272 hours. And what you need to do is to verify whether this is a maximum or a minimum. And I just kind of made a little table for time and a of t, and I know when t is 0, I have 30. I've got my 3.272 hours in here somewhere, and I think that A of that was 27.965, and then you substitute in T equals 8, and I get 48.544. So yes, 3.272 hours is in fact a minimum, just by looking kind of at what the graph is. I suppose you could graph this as well from 0 to 8 if you wanted on your calculator. Okay. All right. Questions on part D?
Yes.
Okay, what's your question on part D?
I just wanted to check to make sure my answer was correct.
Well, okay, we went through the answers at the beginning, Jacqueline.
Oh, okay, that's why, sorry.
Okay, so if you want to check it real quick, you can do that.
Oh, so it's basically just what we found out in C?
Yeah.
Okay, I was wrong. Okay, thank you.
Okay, so I'll leave those up there for a minute. And if we want to, do we need to talk about the second problem with the gravel? Do we need to talk about part A of that one, I guess, would be?
Yes, I got completely different.
Did you use a graphing calculator?
Yes.
Then I don't know what to tell you, unless maybe you're in degree mode and not radian mode.
I somehow got 785.13. I'll just redo it, but yeah.
Yeah, you should. And make sure you're in radian mode and not degree mode.
Okay.
Okay, because that's pretty much, you can pop it into your calculator.
Okay.
Okay. Do we need to talk about B? Again, that's just kind of taking that integral. C?
For that one, you also can't use the derivatives of GT. The other one.
Parts. Let me review the problem, okay, Sarah?
Okay.
Just is the amount of unprocessed gravel at the plant increasing or decreasing? Okay, so what do you want to know, Sarah?
Like Lauren asked earlier, if you could use the integral or not. So
Right.
Because I also got decreasing.
Mm-hmm.
But in the last problem you did, you said we couldn't use the integral.
No, because it's really about the rates. Because you have this rate G of T that the gravel is coming in. You have this rate that I called P of T. Mm-hmm. So here, let's find a page here to talk about this. So this is letter, what is it, C? Mm-hmm. Okay. So I have my G of T, which is gravel arriving. And I had what I called P of T, which is 100, because that's how much, maybe it should be negative 100, no, 100, because that's how much gravel is being processed every hour. Okay. And then what you really want to know is if the amount is increasing or decreasing, that's really about the rate. And so the rate that the gravel is coming is this. The rate that the gravel is being processed is that.
Wouldn't it be 100x?
No.
Because it's a rate.
It's a rate. And it's the same rate every hour.
Okay.
So again, if I wanted to know how much gravel was processed over 4 hours, I would take that integral from 0 to 4 of 100 dt. But the same amount is processed every hour. So the same amount is like taken out of my pile every hour. So again, what I really want to know is, does G, what is it, 5? How does G of 5 compare to P of 5? Is it bigger or smaller or what? So I get that G of 5 is 98.141, and like I already said, P is 100 no matter what. So that's less. So that's telling me that I have more gravel being pulled out of my pile and processed than I have coming in. So that tells me that it's decreasing. The rate, it's decreasing. I'm processing more than I'm bringing in that hour.
Okay, thank you.
Okay. And then do we need to talk about part D? Sarah says yes. All right, so part D says, what is the maximum amount of unprocessed gravel at the plant during the hours of operation on this workday? Okay, so again, what I did was I made myself a formula for the amount of gravel that I have. And again, remember that I start my day with 500 tons of gravel. Over the course of a day, I add this much gravel and I process that much gravel because I process 100 tons of gravel every hour. And so just like in the last problem, if I want to know when it's going to be a max, I find A prime of t and I set it equal to 0.
I have a question just about how you set up the problem.
Okay.
When you say like it's an integral of 100, why didn't you make it 100t?
Because if it was 100t, that would mean in my first hour, I would process 100 tons of gravel. It would mean in my 5th hour, I would process 500 tons of gravel. Is that what happens?
No.
No, I process 100 every hour. It's a constant amount. The rate is constant. No matter how much my dump truck dumps in, I can only take 100 tons of gravel into my machine every hour and process it and make it whatever you turn gravel into.
Okay. I think like when I'm looking at it, doesn't like just putting 100 mean that they just do it once?
Nope.
Okay.
No, because it's the integral. So what I have, if it helps you, because remember we talk about everything in terms of words, which I'm trying to use, an equation, which I'm trying to use, and if I do it as a graph, then it's going to be a straight line like that. And if I want to know, so this is time, this is what I called processing gravel, my P of T, okay? If I want to know how much gravel I processed, I take that integral. And if it's for the first hour, well, then it was only 100. If it's for the second hour, well, from 0 to 2 hours, I process 200.
Okay.
Okay, does that help?
Yeah.
Maybe, okay. All right, so again, you can solve this. I ended up with a time of 4.923. The APCalc exam takes just about everything to 3 decimal places. I don't think that's really going to matter for you because you don't need a calculator for the exam this year, but that is why I am choosing that number of decimal places. And then you substitute that t back into there and just justify that it is a minimum, or a maximum, I'm sorry. So A of 4.923 is 635.376. And that was what the answer was actually supposed to be. Okay. All right, are we good? Yes? Okay. So then we are going to move on to the next type of problem. So I did distribute type 2 questions or type 2 problems to OneNote, and we're going to move on to that. If you want to open that up, you might have to sync. And type 2 problems are about linear motion. And these questions usually set up a situation where an object starts at a particular place, maybe with a particular velocity, and then you're asked questions about how this system evolves. Where the particle is going to be at time t, what its speed's going to be, when and where the maximum and minimum values are. So I want to start by just kind of reviewing the terms that are involved in problems like this. So S of t is going to be the position. V of t is going to be the velocity, which, as you remember, is a vector. And v is going to be equal to ds dt. And sometimes that'll be written as s prime of t. And remember that vector means we can have that velocity being in the positive or negative direction. Sometimes instead of talking about velocity, we're talking about speed, which is the absolute value of the velocity. So we kind of take that direction out of there. And then finally, we can talk about the acceleration, which again is a vector, which means it can be in the positive or the negative direction. And acceleration is dv dt, or the second derivative of the position. And again, remember that I can also write this as, let me write it a little bit better, v prime of t and s double prime of t. Okay, because sometimes those, that way of writing it will be used in a problem. Okay. So if I'm connecting quantities to their derivatives, I can also work backwards and connect quantities using integrals. So you should remember that v of t is the integral of a of t dt, and that s of t is going to be the integral of v of t dt.
Any of these will have jerk involved?
I'm sorry?
Do you think any of these will have jerk involved?
No, I don't.
Okay.
And if they do, it's just another derivative. I've never seen jerk on an AP exam question that I can recall, and I think that's going to be far too fine a detail to worry about in a year like this. Okay. All right, so some other things that you need to note or remember is that there is a difference between the position at any given time and the total distance that's going to be traveled. So the total distance traveled is going to be the integral between 2 points, whatever they are. They can be A and B, they can be T1 and T2, but it's going to be 2 different times. That's going to be the integral of the speed. Now, those of you who are in AP Physics, and we did actually talk about this in APCalc, is that there's a difference between the total distance traveled and the displacement. You can sometimes think of displacement as the net distance. And we often also talk about it, especially in physics, as the distance between where you start and where you end, and it doesn't really matter how you get there. And that's going to be the integral from whatever those 2 times are of the velocity with respect to time. So this is going to be velocity. So for instance, if I travel this way 3 and then back this way 2, the total distance that I traveled is going to be 5, because that's how many steps or units that I took. But my net displacement is only going to be 1, because it doesn't matter that I backtracked, it just matters where I started and where I ended. Okay, does that make sense to everybody? Okay. And then something that you're also often asked to find is the final position. And this is kind of like an accumulation problem in which you don't want to forget about whatever the initial position is plus that displacement. Okay. So I want you to remember again, that there's a difference between average and instantaneous values. Okay, so let's talk about that. If I'm talking about velocity, for instance, then the average velocity would be whatever distance I traveled divided by the amount of time it took me to travel that distance. It wouldn't really matter if I traveled the same speed that whole time. It wouldn't matter if I stopped in the middle. It's just simply a matter of how far did I travel and how long did it take me to do it. Instantaneous, on the other hand, is when I take the derivative of my position function and I'm talking about what is my accelerate or what's my velocity at any particular specific point in time. Okay, and you might be asked a question where you want to know when does the average equal the instantaneous or something like that. And this also comes back into the mean value theorem. Okay, that your instantaneous value of a function somewhere must be equal to the average value of that function on a closed interval. Okay. And the last thing that I want to talk about before I let you practice a problem is how do you tell if the speed is increasing or decreasing? And we talked about this in class. We talked about this on a test or a quiz problem. And remember that it has to do with what the direction of the acceleration and the velocity are in. So if your object is speeding up, that means that the acceleration and the velocity are in the same direction. It doesn't have to be positive necessarily. They could both be in the negative direction and my object would still be speeding up. If my object is slowing down, that's because A and V are in different directions. Okay. So there are three basic types of problems that you're going to run into. There's going to be problems that involve equations. There's going to be problems that involve graphs, and there are going to be problems that involve tables. Okay, so we will try one of each. We'll do one today. I will post the homework to make sure that you're doing the correct problem, and then we'll do two more problems on Monday. So if we go here, yeah, let's see. Oh, nope, not what I want to do. There we go. So you should do this first problem here from 2017. And I'll give you 6-7 minutes to work on that, and then we'll go over it. And then we'll do the other two problems on Monday, but I will update the portal to let you know what you should do for homework. Okay, because I only want you to do the same problem that we went over. So go, be free, work on it. So these are the answers to the problem that you should have been working on. Let's start with part A here. Did everybody get part A? I'm sorry, that's not a good question. Who needs to see or talk about part A, and I need you to use your voice?
Did you like just plot all of it, or did you like? 'Cause like I know it says without a calculator, so like.
Right. Well, so if the particle's moving to the left, that means that v of t has to be less than 0, right?
Yeah.
So you just take the derivative
Yeah.
of the position, and then you make sure that it's less than 0.
So you just have to plug in 1 through 8 and see what.
No. So I get that derivative is equal to 2 times t minus 1 over t squared minus 2t plus 10, and I want that to be less than 0. Now,
Oh, so you just solve for it.
yeah,
Oh, okay. I'm just silly. Okay, thank you.
okay, it's okay, it happens. All right, how about part B? Are we good with part B? I'm sorry, wrong question. Who needs to talk about part B, and please use your voice?
I do.
Okay, so for part A, we'll go to part B over here, okay? For particle P, we know that between 0 and 1, it's moving to the left. And so from 1 to 8, it's moving to the right, correct?
Mhm.
Okay, so for particle Q, I know that v of t is t squared minus 8t plus 15. And it's going to change direction every time that this is equal to 0, right? Yes?
Yeah.
Okay, because that's going to be where v is equal to 0. So I can actually factor this, and I have t minus 5 and t minus 3 is equal to 0. So my particle is going to change directions at 3 and 5. So then it's just a matter of which direction is my particle moving between 0 and 3. So if I plug 2 in up here, that's going to give me 4 minus 16 plus 15. So that's going to be bigger than 0. So my particle is moving to the right. From 3 to 5, if I put in 4, that's going to give me 16 minus 32 plus 15, and that's going to be less than 0. So my particle's moving to the left. And then from 5 to 8, I'll pick 6. Okay, so that's going to give me 36 minus 48 plus 15, and that's going to be positive. Okay, so now it's just a matter of comparing these two. And I can see that from 1 to 3, they're both moving to the right. And from 5 to 8, they're both moving to the right. Okay, does that make sense? Okay, so I'm going to put up for a minute the answers again because we are technically over time, and I know you have another class to get to. You should still try to do the first homework problem, which is 2016 number 2, which actually I think I posted incorrectly. So I will fix that. Yeah, I totally messed that up. I will post that on the portal, but you should try to do the first homework problem. Okay? Questions? All right,
Can we stay
then.
after for a minute to ask you questions?
Yes. Okay. But I've got to write that I have to fix the portal. So go if you have class. This is really supposed to be 216 number 2.
For number, do you have to? Because like I like filled out both like for acceleration, like when acceleration was 2, and then also when velocity was 2, just to make sure that they were the same, like, or that they, no, not the same, that they were contradictory to confirm that they were decreasing. But
You mean for part C? Wait. For part C, Jacqueline?
yes.
Okay, you cut out when you said what part you were
Oh,
talking about.
sorry.
Not your
Yeah.
fault. Okay, so part C, yep.
You have to verify that it's both A of T, or sorry, A of 2, and then B of T, that there's contradictory, right?
That they're in opposite directions. Yep, you do.
Perfect.
Because
And
I
then,
think because that's part of explain your reasoning.
Okay, perfect. And then for D, I don't know why I don't remember this. I just do not remember. Like, this was about one of my harder units for me. I just don't remember how to find D for number D.
Okay, well, did you look at the notes that you took today?
Yeah.
Because it says how to find the position of the particle.
So it's just one of those, like, but like for the first time it changes direction. That's what I got.
So in part B, you figured out the first time it changed direction. When does it change direction?
For B, it changes, well, multiple times.
The first time it changes direction is where, Jacqueline?
1?
No, we're talking about this particle over here. Where's the first time it changes direction?
When it's the 0 to 3?
It doesn't change direction from 0 to 3.
Oh, sorry, then wouldn't it be the 3 to 5?
It doesn't change direction from 3 to 5.
Or
Where,
3?
what time does it change direction?
3.
Yes.
Oh, okay. So you just plug, oh, okay, so you're just using that plug-in. Okay, I'm just overthinking this. Okay. All right, well, thank you.
Okay.
All right. Thank you very much. Have a nice day.
Sure.
For that one, for D,
Mm-hmm.
wouldn't you have to take the antiderivative to find the position of it? Because I'm confused how you got 23. Like, did you just plug it into the V?
No, because what I want is position.
Yeah, so I took the antiderivative of V.
Okay, which is another way of saying the integral, which is really the important thing.
And I plugged that in my calculator and I did not get that answer. I didn't get 23, I got 18. Both ways, I did it.
Sarah, look at your notes for today. And what do they say under find final position?
Initial plus.
Yes, and do you know what the initial position is?
5.
Plus 18 is 23.
Gotcha. Okay, thanks. Thank you.
So that is such a common mistake. And that's why I try to make a big deal out of it, because I do it myself. Because it's just like this tiny little sentence that they sneak in there, and yet you have to pay attention to it. So
yeah. Okay, thank you so much. Have a good weekend.
You too. All right, Helen, here's the thing.
Can I stop recording?
Well, here's the thing. If I'm going to have a meeting with you on my own, I have to record it.
Oh.
But I don't think that everybody who watches this video needs to hear our conversation. So why don't you leave?
Okay.
I'm going to stop the recording, stop the meeting. I'll restart my meeting. So give me like 2 minutes and then come back in and I'll record our conversation and send it to Miss Cunningham.
Okay.
Okay? All right. Thanks.